or maybe of other protection, like kind of not getting deterioration of your properties, like maybe acid resistance, etc. Or sometimes we want to use it in the certain environment, something like gases environment, or kind of some toxic media and all. So to protect them from the those kind of environment, the people also usually coat those product to make sure that your product is not getting damaged or something. So of course, it's also been used for kind of ornamenting or decoration purpose. Okay, and the best thing is that depending on the application. Suppose if you want to protect it from the corrosion purpose, like oxidation purpose, you can use some sort of polymer-based coatings where it enhances your this one corrosion resistance as well as the wear resistance. Okay. So of course, the nanocomposite is also used for coatings purpose because means instead of putting those Bristine or the controlled polymer-based coatings, we add some kind of nanofillers. It enhances the further properties like thermal resistance or the resistance, etc. Okay, because of their nanomaterials unique characteristics of the properties. Okay. So if you see the overall fabrication method, we have plenty of techniques, but among them, like there are three major techniques. Like dip coating is a laboratory-based one, and then we do have a spin coating method, and then electrodeposition. Okay, and of course, for the process for the dip coating, you're gonna soak your substrate. For example, if you want to coat your metal substrate, you're gonna dip your first you're gonna prepare your polymer solution or any other nanocomposite solutions. Okay, and then you're gonna dip your metal substrate. Okay, and then you take it out and then you dry it at oven, and then again you dip it. Depending upon the thickness you want. Okay, as well as the amount of layer you would like to have. And in case of spin coating, your samples will be rotated at certain RPM here. Okay, and then you're gonna drop your prepared coating solutions, and that will be dispersed or the sprayed on the surface of your sample or the metal substrate. Okay, and again, either you can dry it or you can leave it away, because this is spread throughout this surface. As a result, they get dried instantaneously. And for the electrode deposition, of course, the electrolyte solution you will have to prepare. The electrolyte solution is made up of this nanocomposite solution, and then you will have anode and cathode. And by optimizing those pH and the distance between the electrode and the temperature, all these things, you can deposit those metals or the nanocomposite solutions on the electrode. And there are sometimes, if you use some sort of like a rubber or some sort of protein based one like collagen and all, you will have to dry them, and sorry, you will have to cure them with the help of either UV or some other radiation sources, and then finally you will get a coating. So for the thin film, or we also say the thin film. Okay, uh, again you have a various process like chemical process and then physical based one. Physical means you're gonna melt that substrate and then you're gonna deposit on the surface of the metal, etc. The physical means chemical means you're gonna have the media or the solution form of your coatings, which you are going to coat on the substrate of metals, and then you're gonna maybe do the deposition, or you're gonna spray it, or you're gonna do that sol-gel method, etc. So yeah, this all you have seen, right? Spin coating, all these things. You have done SEM, right? In your third, second year, no? SEM, you might have done that gold coating, right? That is best example for deposition. How you gonna spray your, gold on the surface of your, metal sample or the polymer-based one before you start to analyze your morphology. Okay. So same things, mechanism for spin coating. Okay, this is how the machine so looks like this, and you're gonna mold, your this one substrate, and then you're gonna deposit your coating solutions, and then it rotates at certain RPM. As a result, the your coating solution will be dispersed throughout the surface of your metals. Okay. And dip coating is very simple. You're gonna dig your sample, dry it out, and then subsequently, the coatings will happen, and you do the repeated method, and then you'll end up with pretty good thickness. And electrode deposition technique, as I told you that, I mean, you have to first prepare the electrolyte, okay? And that electrode again, I mean, which can be a combination of matrix and different fillers, so that you can have those multifunctional features, for example, uh, anti-corrosion resistance, and then tribological properties, like you can improve the scratch or the wear resistance, and also for the biocompatibility, because whenever you expose your product or the substrate into the biological applications, like your surface is going to interact with the cells or the tissues. Okay, so if your surface itself has very good biocompatibility, that will be pretty much, I mean, good actually, to make sure that your product is not inducing any sort of toxicity. So, make it full straight. Well, this is how your this one your electrodeposition method, like yeah, electrolyte which has positive and negative ions, and they usually they should conduct the current actually. If you don't have the conductivity, the I mean the electrolyte will not start to deposit on the substrate. Okay, so sometimes they use some I2O plate also. I mean for certain applications. Okay, so with the help of this, I mean delta, I mean difference in the I mean the applied potential, voltage, you can enhance or catalyze the deposition of your, metals. Okay. And of course, if you use some nano composite based media or the electrolyte, what will happen? The nanoparticles will start to settle down. So during the process, they also used to have some sort of that, magnetic stirrer, so that the nanoparticles, they'll start to deposit along with the matrix. Okay. So finally, the electric current, they'll start to apply. And then the positively charged ions from the anode will start to deposit towards to the negatively charged cathode. Okay. And yeah, this distance, and then how much your charge, the electrical current you are giving it for the deposition, all these things will decides the deposition of your morphology, as well as the thickness. Everything will decide. Sometimes what will happen, you get some aggregate, and the thickness will not be uniform. Okay, so all those things will be varied depending upon the, the conductivity of an electrolyte, as well as how much voltage you are giving, as well as the distance between the electrode. Okay. Yeah, same. These are the driving force which applies to have those better morphology or coating thickness. Okay. And you can also use some surfactant, as well as you can play around with this flight time, etc. Sometimes they use some sort of like sinusoidal based, applying electrical current actually, like 2 seconds on and 1 second off. That kind of differences in the applied voltage potential also people apply. Okay. And this is some of the example, like how the potassium is getting coated on the cathode, and some of the reduction as well as oxidation reactions. Okay. And you can see one of the example, like fluorinated hydroxide coatings on the surface of titanium substrate. Okay, because titanium is widely used for implant applications. Of course, titanium is not inducing, they don't have that capability to induce mineral deposition or osteogenesis property. Okay, so if you want to use implants, out of titanium-based metals, you should induce those kind of mineral deposition properties. If your titanium doesn't induce osteogenesis, it cannot be that useful for bone tissue regeneration. So they doped, they did this fluorinated hydroxide on the titanium substrate, okay, and then they played the current density of electrode deposition method from 6 MPa MA to the 30 minutes with a different concentration of fluorine. Okay, so you can see here with different current density, and their different concentration with the constant current density, how the morphology is changing. Okay, so with increasing the morphology, the concentration of fluorine, you can see the changes in the morphology. You get some sort of like flake based structure here, and the flake is again transforming into kind of flower-based images, like which has a pretty high surface area. And yeah, again, you can see the changes in the coating thickness. Here you get, I mean, kind of uniform thickness, and that was not observed here in case of flake-based one. And you can also play on with the temperatures, like during the deposition. I mean, the hydroxyapatite precursors like a calcium-related and diammonium hydrogen phosphate. So if you increase the temperature, all these things again, that will be, I mean, shown or reflected in the nucleation growth as well as the, I mean, nucleation rate. Okay, that again you can see the formation of different flakes into the nanorods. Okay, and again, if you change the current density also from 40 to 60, you can see the morphology changes. Okay, so basically morphology changes again. It helps for playing the role of surface energy and surface area. And once surface area increases, again you can enhances those surface properties. Okay, the coating thickness will be optimized, and your properties like a tribological properties will be improved. Okay. And this also used in, I mean, MEMS, I mean, microelectronic manufacturing and semiconductor devices, etc. Okay. And if you want to fabricate some bilayer films and all, this is the best technique. Okay. So you first fabricate, I mean, the first layer with the other precursors, and then you go with a different electrolyte solution, then you'll get those bilayer, I mean, films. Okay. And how to measure those properties? Do you ever thought of those things? Coating, I mean, nano coating or the whatever you deposited, how to measure it? Whatever you have seen the morphology, that is kind of examination, how thickness, etc. But if you want to measure that coating property, how do you measure it? Have you ever come across this word nano indentation analysis? You guys might have read it. This guy,
We were given this topic for project, but not in the course. We haven't come across it yet. Nano indentation, not yet.
Okay. No, this Bharatwaj and Pravan, you might have read, right, somewhere in the article, research article, papers. No, right? No?
No, sir.
Okay. So this comes to the biggest questions. Okay. So whenever you make a coating based material, I mean the morphology, so you have to study how strength of your coating. Okay. So once you've done the coating, there are some micro analysis or the nano analysis where you can, I mean, find out the strength of your coatings. Okay. Harness, you might have seen the Rockwell harness and Barkol, Brinell harness, all those things. You are going to intend, I mean, kind of some balls into the surface, onto the surface of your material, and subsequently, how much depth is going to penetrate. So the same principle is going to apply here. The changes is that the intent that what we are going to penetrate, that is going to be very small. Even you can't see from your, I mean, naked eye, like kind of uh, the sizes of less than 100 micron or I mean 1,000 nanometers. Okay? So that is called sometimes nano indentation analysis. So these are, you know, like harness, like Brinell harness, what kind of indenter you use, like a 10 mm, I mean, indenter, and the micro harness, what kind of indenter you are going to use, etc. So nano indentation means that it's like indentation method mainly, I mean, vastly used to study the hardness of the nano composite coatings or the nanomaterials. Okay. Uh, you know, I mean, the carbon nanomaterial, like carbon nanotubes and all, they are saying that the modulus is even, I mean, pretty high than the stainless steel. So have you ever thought of how they studied the single nanotube strength? I mean, mechanical properties of the single nanotube. So you do that, do this homework. We'll discuss tomorrow. Okay. So are you getting it? What I'm asking? You might have read, right? The carbon nanotube has the excellent modulus. Even they dominate. I mean, better than this stainless steel and all. So have you ever thought of how one have studied that mechanical properties of single carbon nanotube? Because the carbon nanotube diameter is less than 100 nanometer. Of course, it has got high, I mean, lengthy. I mean, but how they studied the single nanotube strength? Have you ever thought of this thing? Just do that. I mean, homework, huh? So the nano indentation is specifically used for those purpose. So again, it measures how much the indentation happen, or you also get a load versus a displacement. Graph. So this is how the indenter looks like this. I mean, it used to be in the, geometry, like less than 1,000 nanometer. They're very sharp, and they used to mount it with the help of like robotic, like a soft robotics in the instruments. And then, they start to, indent this, indenter on the surface of your materials you want to analyze. So, I mean, the indenter also has a different geometry, like a spherical tip, and this has a very sharp tip. And depending on the kind of applications you want to use or measure it, okay. And the data you get like this, like you are going to apply certain load, and then you are, holding it for some time, and then you are releasing the load, and then you're gonna see how much the displacement was happening. So that is what you get, like loading it, and then you are holding it, and then you are completely leaving the load for, from the surface, and then you see how much the, displacement happened. That means how much did the indenter, progressed. So that was a story about the, the how to read the mechanical properties of your nanocomposite coatings, etc. So, we have other types of coating, or kind of like microfabrication techniques. Like you might have seen in your computer motherboard, there are some of the designs. Like I'll show you. Yeah. So you can see these kind of designs you might have seen, in your computer motherboard, right? So this also can be fabricated with the help of deposition method, or slightly the other word, like kind of lithography method. So that is also nothing but you are writing the molecules, and or you are going to deposit your precursors material on the surface of metal or the plastics, and the depositions will be of the sizes in the geometry of micro or in the nano ranges. Okay. So which is nothing but nano imprint lithography. Okay. Sometimes it is also called like a hot embossing technique of imprinting nanostructures on the substrate. Substrate may be a polymer or the metals. Okay. See, for example, like I wanted to have this kind of geometry. Okay. You can also see here. Okay. There are some substrate which are having the dimensions of like less than 1,000 nanometers, and which are slightly, up from the substrate. Okay, it's kind of comes out from substrate. The best example, you might have seen some of the wedding cards, like the surface was slightly, comes out from the substrate. Okay, kind of embossing we used to call it. So, I want to have either embossed one, or kind of this kind of, upper nail, kind of having the geometry of micron level hold something. So if you want to have those kind of geometry, so how do you fabricate? Either you can go with 3D printing. So straight away you can have this substrate by printing. So with the help of 3D printing, you can print multiple layer, and then you'll get this kind of shape. If you don't have 3D printing, with the help of deposition, like nano imprint lithography, you can fabricate those geometry as well. Before that, what you have to do, you have to make this mold first, actually, the top one. So once you make the mold, with the help of CAD design, or combined with the CAD and the casting technique, you prepare this mold, and then you have this substrate, and then the media, sorry, the coating, what you want to, have it. So that you apply on the surface. Once you have done it, and then you push this mold towards this, coating which was applied. The moment when you're done, you apply the pressing, and then you do all those things like post processing, either maybe of cross linking, etc. And then you take them out, and then you will end up with this kind of patterned structure, or geometry. Okay, and then you cool it down, and then you'll get the structure you would like to have. And this is not new, and which is it is there from long back. But we are applying to our applications now, actually. So you can see here some of the dots, I mean, which are fabricated with the help of those nano imprint lithography, which is having the sizes of less than 200 nanometers. This also was fabricated using nano imprint lithography. You can see different channels, etc. And their thickness is I mean, it is less than 200 or 300 nanometers. So we'll stop here and maybe we'll see next us like some other fabrication, microfabrication methods. So you all have placed now from your class. Placement is going on, right? Many people are telling that